afternoon, everyone. Thanks for coming along and giving me some time today. My name's Jack. I work at Google on Chrome tools, and specifically today I'd like to talk to you about the Chrome MCP server, or the DevTools MCP server, I should say. For those who might not have seen this, this conference was timed really, really well for us because this shipped last week. So there is now an official Chrome DevTools MCP server. It's very early on, but we'd love any feedback you have, so please feel free to download it and give it a go. If you have, I'd love to hear how you've got on, so please feel free to just come and grab me during the rest of the conference and chat through. But what I want to do today is really talk through kind of the journey we went on and the challenges we have had and continue to have along the way, and some of the things we've learned that maybe you can apply to your tools as well. And so we're going to split this talk really into three sort of broad sections. The first is talking about how we've adapted for building these tools where our sort of immediate consumers are not the humans anymore. And that was something we did early on, but then we realized that obviously all this text we're producing or information we're sending isn't being read straight away by a human, it's going into a tool. And that can shift how you think about things slightly. Also want to talk about a lot of the learnings we've had along the way. Trust me, we've done a lot of things wrong and made a lot of mistakes in our sort of AI journey thus far. Obviously with it being a very new topic to probably everyone in this room. And then finally, challenges we've had, both ones that we've had and feel like we've got a grip on and solved a little bit, and also ongoing challenges that really I'd also love to hear how other people in the room are solving this. As I said, AI tooling and building tools with AI is a very new field to lots of us, certainly myself, and there's still big open questions that we have that we're kind of thinking through. So the first thing is around building for AI users and what we mean by that and how that adapts what we actually want to build. Early on in some of our experimentations with building tooling for AI, what we would then do is we'd turn off our custom tools and we would just try asking the LLM the same question, but without the tool we were experimenting with. And more than once, we found that actually it didn't need the tool we'd built in order to give a good response and actually debug the problem. They were pretty smart, relatively, out of the box. And so we ended up having to think about how we could make sure we were providing value. And so it was really a case of asking ourselves the question, what is the value proposition that we can provide that enables an LLM to do things that it can't do otherwise? In the previous talk, Richard touched upon this a little bit as well and set me up nicely. So I don't think he's here to know it. But we actually turned to asking ourselves, what would be some prompts that users might be entering into their MCP client that we would want to be able to help an agent solve? So for us, that's things like verify in the browser that your change works as expected. If either your AI has made an edit for you, or you've made a change and you want to resolve it, or check that it works, you might want to ask your MCP client to do that for you. You might have a problem with, let's say, some images on your local machine not loading, and you might want some help with that. I think we've all probably debugged complicated forms where you have to fill in 5 different inputs before a certain bug appears, and sort of doing that on repeat as you try to debug is very boring and very painful. So it'd be amazing if we could provide tools that you automate that process within Chrome. And then also, I've worked on performance tooling for the last few years, things like Lighthouse, the performance panel, all that kind of area. And so we also wanted to make sure we provided some help for performance as well. So my website is loading slowly, please can you help? And these were some of the things that we felt if we could provide a good DevTools MCP server, we could greatly enhance the abilities that your AI and your clients have. Can we enable an AI to answer these prompts well? And that leads us to think about what can DevTools give AI agents that no one else can? Like what are we as the sort of DevTools able uniquely to provide? One of the most obvious ones is runtime data. Statically analyzing code can give you a lot of information. We can look for problems there. But we have a wealth of knowledge about what's actually happening in the browser when your website runs. And that can be really valuable to help debug or pinpoint an issue. We also know that today the web is built on a lot of abstractions. And one of the things that means is that the code that you're writing in your text editor probably looks very, very different to the code that's being executed in the browser. But in DevTools, if you have source maps enabled, we're able to help jump from minified production code into the source code that you wrote in your editor. And we can help the AI as well have knowledge about where the minified code and the errors in that, where they can map back to in your source code. And we just have a lot of debugging capabilities. I'm hopeful that a lot of people in this room have used Chrome DevTools at least once. And you probably know there's a bunch of things you can do in there to debug your styling, layout, performance, memory, network, all sorts of stuff. And so we can expose all that functionality to an AI as well. And although we've only just shipped our MCP server, we've been working on AI tooling in DevTools probably for a couple of years or so now. I think first shipped about a year ago, give or take. So we shipped last year the AI Assistance panel in DevTools. So here you can be interacting with DevTools, pop open a panel, and enter this sort of fairly classic chat-style interface with your AI, where it can inspect what's going on and try and help you debug through a problem. What was really nice about this is we got to work on this in an environment we were comfortable with, which for us is the DevTools UI. But it let us figure out some things in this topic which none of us had really worked in before. We were complete novices kind of starting on this journey. But all of this, I would say, has really helped us form these opinions and this plan for the MCP server. The first is the fairly classic one. It's learning how on earth to prompt these things, like particular phrases, particular techniques that work well. One of the things I've really appreciated about the community as a whole is there's a lot of wealth of knowledge shared freely, openly from all the major players and lots of people. And that's been really helpful in sort of figuring out how best we prompt and manage these things. When we first built the AI assistants in DevTools, function calling wasn't really a thing. It wasn't well supported. And so we sort of had our own hacked-together version of that to enable the AI to dig into, say, styles on a page to help it debug an element. But we had to kind of throw that away and relearn all over again when function calling became a first-class citizen in all the APIs. And finally, context window engineering. This is something that I think, honestly, were quite naive about. I remember saying to someone, there's no way people will fill the context window. We don't really need to concern ourselves with this. And then someone reported a bug where they debugged a website with 400 network requests and promptly filled the context window before they'd even started. And so we very naively thought this wouldn't happen. It absolutely did. And what we've also been able to explore since is a lot of techniques for how we can represent quite chunky bits of data in smaller formats without losing quality in terms of the output from the AI. I'll give you just one very quick example of this. So when we're looking at AI performance tooling, we have to represent call trees. So this is like flame charts in the performance panel that show you how long functions took and how long those children took to execute within that, and you can look for hot functions that are slowing your app down. Our first pass at representing these in sort of textual form that an LLM might understand was something like this. So we have all the URLs at the top, so we don't repeat them a bunch of times. And then we have this call tree, and we have various nodes. But looking at this, you can see it's pretty inefficient if we're thinking about space and token usage. There's lots of repeated content. For example, the children, here it says to evaluate script, and that same text is repeated just below it. And so what we started thinking is, are there more compressed forms we can represent this data? Because really, this first pass was, well, if a human needed a textual representation, this is maybe what it would look like. But obviously, we weren't giving something that a human was going to sit and read. The human's got DevTools and the flame chart. So we ended up experimenting, compressing the same data into this much more compressed format. We use semicolons to separate it. It's really CSV with subtle couple of differences, mostly semicolons. And then a bit of information in the prompt to tell the LLM about this format so it can understand it, and so it knows what all the columns map to. I'll be honest, I thought this could completely fail, but actually we were able to swap to this format without any sort of loss of quality as far as our sort of evaluations went. And this roughly reduced the token usage by about 50% for these particular cases. See some more, some less. And that was really, really beneficial to us. Something that I think was also touched upon actually in Richard's talk previously was looking at finding the right abstraction level. So in the talk that's just been, for those of you who are in the room, Richard was talking about how counterintuitively dumber tools make agents smarter because they're easier to put together. And that's actually something that I was very happy to see him talk about because he really set me up perfectly. We actually built an MCP server before. It never made it public. It was internally used and tested a bit. And we exposed high-level tools. So we might have a debug performance problem tool and a debug styling problem tool, and you imagine others like this. And really what these did is they mapped one-to-one to the AI assistants in DevTools. It was really us trying to take what we had in DevTools and get it into an MCP environment. However, to be honest, when we did that, we shared it. People weren't that infused. We didn't feel too great about it. It really didn't actually work. Like, it didn't provide too much value. The problem was that firstly, we built these quite high-level tools that were very niche. So if you were loading up DevTools to debug a very specific page load performance problem, great. The performance tool was going to be the one for you. Solve your problem, no problem. Solve your problem, no problem. Try and say problem a bit more. However, if you were just in a general debugging session, you didn't quite know where the issue was, you wanted to go through a few different parts of DevTools and figure it out, then this tool was suddenly so focused that it wasn't actually very valuable to you. And that was true of all of them. It also created a very complex setup process. Because we wanted to reuse what we had in DevTools, to set up the MCP server, you then had to set up a new Chrome profile. You had to sign into that profile. You had to enable the AI features in DevTools. And it took setup from dumping the config into your editor into a sort of 15-minute process, which, let's be honest, none of us are going to do long term. And it was also hard when the AI client really didn't have information about the browser. In the debug styling tool code a minute ago, one of the inputs we asked the AI to give us was the CSS selector, like the relevant element it's trying to debug. But it had no way to actually get that reliably because we weren't giving it any tools to list the DOM structure of the page. So really, we were very unenthused by our first pass at the MCP server, and that's what led to us taking it a step back. So our second version, which is the version that has now been released, we looked at exposing lower-level building blocks that could be composed together and given to an AI. And really, we thought about this in the lens of what are common actions that users do all the time when debugging web app problems. So that's things like, testing an interaction by clicking or hovering over a button. It's filling in a form 10 times as you try and figure out the interactions or the bug with the logic in your form. Maybe you're resizing the page to test your responsive CSS across a particular viewport. I'm biased because I work on performance tooling, but maybe you're recording performance traces to debug some performance or core web vitals. Or maybe you want to execute some script in the DevTools console to help you debug something. These aren't absolutely every tool we now ship, but this is sort of a set of the tools that we shipped. And you'll notice here there's no high-level debug my problem. These are all very granular tools that you can compose together as part of a debugging workflow. And this also greatly simplifies the setup. The nice thing about the new MCP server is that you just dump it in as you do any other MCP server. There's no setup required, and the MCP server itself will spin up Chrome for you and manage that for you. We still make use of all the code in DevTools, but we do it via reusing the actual code rather than calling into DevTools itself. Of course, I have to have Gemini CLI there, but I suspect there may be other clients available if you wish as well. And so finally, what I'd like to do is talk through some of the challenges that we faced and continue to face. And these really are the areas where I'd love to hear how others are solving this, so please feel free to come and grab me afterwards. I'm a sort of classic software engineer. I like nothing more than having a feature to build. I write my tests, I write my code, I have that quick feedback cycle. Once all my tests are green, I've written them all, I know that my feature is done, and it works for everyone, and I can go home again. The world of AI and its non-determinism is very stressful to me personally. I don't like it, and I miss the old days, but I think I need to sort of move on. But the amount of different environments that we have to deal with here is actually pretty overwhelming. If we start thinking about just the amount of clients that are available, and obviously there are also ones like Gemini CLI, Claude Code that come with the model built in, but there are also lots where you get to pick the model. So you take all of those, plus many, many more that aren't on the slide. Then you add in all the models. This was just my VSCode the other day when I took a screenshot of it. And sort of my test-driven, deterministic developer head is losing its mind at this point because I've no idea what to do with this. The variance in the user experience across this and across all the different choices of models and clients and versions and all the rest of it is pretty mind-boggling. And honestly, I don't really have a good solution for this other than to make peace with it and try and do our best to test as much as we can. More than once in our internal testing, we had sort of an interaction like this where, oh, I'm using a particular client and I've noticed that it's using these tools in the wrong order. It doesn't really make sense. Okay, so I look, okay, right, we'll tweak the function description to try and make it clearer that it should do this before this or whatever it may be. Then wait 2 days later, someone else pops up in chat and says, oh, I'm using a different client, and now it doesn't call these functions in the right way. So it's a little bit of a sort of arms race of never-ending tweaking. And honestly, I don't really know how to solve this. I think the answer probably is evaluating as many different versions of this as we can, and also probably coming to peace with the fact that there are always going to be these as new models and clients roll out. I don't think we can ever fully get on top of this. Just try our best and also try to make tools and use prompts that are fairly generic and don't hone in or really target one particular client. So one part of that even is just making sure across the team we're testing across a wide range of clients, stuff like that. So that brings me on neatly to evaluating our changes. And again, sort of Jack of 5 years ago, before he'd even heard of ChatGPT, code review was very different to how it was now. These days I get pull requests, improve the function tool descriptions for performance tools. And these are all the things I would have looked for in a code review that isn't touching AI. You look at the code quality, right? Does it follow the conventions of the code base? Does it use the right features, so on and so forth? Are there sufficient tests for this feature so we know it's working? Is it well documented either to users if it's external feature or internal documentation to us? And then does it work? And does it work used to be relatively straightforward. You might be able to tell just by looking at the code. You might pull down that developer's pull request, fire it up locally, spend a few minutes clicking around and just be confident. Or you might have seen there's other integration tests or an end-to-end test that proves it's right. But in an AI world, how you do this last bit of does it work, is very hard to do because it can work, and you've all seen it, right? You test your tools a few times, you're confident, you share it with a colleague for them to test, and it doesn't work first time, even though they use a prompt almost identical to yours. Over time, obviously, we hope that gets better. So we're also now, though, beginning to explore a world where we can have an automated evaluation suite that helps us judge the quality of output of our AI tooling. The sort of ideal that we're reaching for here is if I send one of you a pull request where I've made a change to, let's say, our prompt, I can also include output from our test suite that will tell us that the score or the sort of quality hasn't decreased. And ideally, hopefully, I've increased it if I'm doing my job well enough. And so when we think about evals, we're sort of early on in our exploration here. But the way we're approaching this is to get a really good data set. For us, that's a set of websites, probably a lot that we build ourselves, maybe some open source ones, depending on licensing and so on, that are representative generally across the web as a whole. I don't know if you've been on the web, but that's quite a big data set to be representative of. There's quite a few variants there, so that in itself is quite a daunting task that we're beginning to tackle. But then we also need to make this tooling really easy for developers to use. If I've just made a change locally, I need to be able to run something to get this output very quickly. If it takes me a few hours, if it takes me a lot of time and jumping through hoops, then we're not going to rely on this. And then we're trying to figure out how best we actually evaluate the quality of our output. There's been a lot of research on this, and I'm far from an expert, so I won't dive into this at all. But we're looking at the LLM as judge approach. We can either give it sort of a golden response and ask it to score our output based on what we think a perfect response would be. We could give it the old and the new responses and ask it to pick the winner and do that a bunch of times and compare. There's loads of different techniques here that we're looking at. So just to give you a brief idea, like this is an experimental kind of early thing that won't actually be used in this form. But we've been looking at collecting data. So in this case, the V1 through 6 on the left is output from DevTools for a particular input, which is a website that has a bad LCP, which is largest contentful paint. So basically, when does it paint to the user? And V1, V2, V3, and so on were all taken sort of a month or two apart. And we've just been experimenting with, can we produce scores for these things that give us sort of a fairly accurate representation of how good they were using an LLM? And so this is the kind of thing we're exploring. I don't really know what form this will take at the end of the day. And if anyone else is sort of on this journey, I would love to hear more. That's kind of where we're going with this. I think because AI and tooling has moved so quickly over the last couple of years and sort of people have been ramping onto it, we've been in a position where we've been able to iterate quickly, not worry too much about doing vast sets of evaluation and ship and iterate very quickly. We're getting to the point now where across DevTools and now with the MCP server, we will have quite a lot of established users. So it becomes more important to make sure that we don't break those workflows as we roll out new features. Another thing we're kind of exploring, and we don't quite know how best to hold, is this idea of supporting richer output. So right now, all the output from our DevTools MCP server will be text. It's markdown formatted in various ways. But the MCP spec does allow for images and audio, but for us, images seem particularly relevant. There are lots of places where, as you're going through this debugging journey with your MCP client, you might want to have a bit more of an idea of what the AI is up to. Sometimes, you might want to see that it's going down the wrong path and you can tweak it or change its direction. And you want to know that rather than have to wait all the way till the end. And there are lots of places in DevTools where an image really does give a really good representation of what you're looking at and what it's up to. So we can imagine our MCP server, maybe it does send a flame chart back or a screenshot of the flame chart from DevTools to help you understand the bit of code you're trying to optimize. Or maybe you're debugging a CSS problem and we can dump the box model visualization we have in the MCP response. We know from our user testing that people want this, like they want to see this output and they want to understand what the AI is doing. But we don't really know how best to handle this. We also don't really know how MCP clients are going to handle this, how much users are going to see this. And honestly, we also don't know what this means for terminal users like Claude Code, Gemini CLI, and Goose and others. We don't know what this will look like for them and if they'd even see the images. Does that matter as long as the AI gets them? We don't know, honestly. I think there's a whole world of figuring out how best to use all these tools. And obviously, the MCP spec also continues to evolve. Speaking of evolving, I'm probably not the only one in here who feels the pace of change is pretty relentless. It's pretty tough to keep up with, both as a user of AI tools and a developer trying to build features and integrate AI into the features we ship. The movement in this space has been pretty crazy, but I don't think it's slowing down at the moment. We've already heard today about MCP specification changes and new versions that are coming and the new features that will be enabled via those. Of course, it's not just the spec that has to change, it's then all the clients that have to update and make use of those new features. And then it's up to us to decide at what point do we consider enough clients to support a feature that we can rely on it. What we don't want to do is have a world where to use our server effectively, you have to stick to a particular client. As I think Angie said a couple of talks ago, that's not the point of MCP. We want to make sure we let everyone use us regardless of which client they're choosing. New models are coming along all the time with new capabilities, bigger context windows, more this, more that, and more buzzwords along the way. We need to make sure that we're reacting to that and making sure that our tooling is still good as those models change. And finally, I think no one really understands exactly how best, from a UX perspective, to work with these tools yet. I think we're coming out the end of the sort of chat bar in your app phase of AI. That's served us well. I think people are beginning to think about more seamless experiences where we can take an existing UI like DevTools and we can actually put AI help into what is already there rather than having it in a very distinct sidebar or something. So I hope that was an interesting look into some of the things we've been thinking about on DevTools. In terms of what's next for us, I'm really here just to ask you please to give it a go and let us know your feedback. As I said, it's the first version of this thing. We've shipped a few releases since, but this is still early on. We're still figuring out what works, what doesn't. As you know from the rest of the slides, evaluating this stuff is very hard. We've done a bunch of testing, but honestly, we can't get close to having lots of people using it on all their various jobs that they do and all the different websites you're debugging. So please feel free to get it. It's all public on GitHub. It's installed just like all the other MCP servers. Very easy to get going. If you do have any immediate feedback or you've tried it, or you have questions, please feel free to grab me. I'll be around for the rest of the day. And with that, I'll just say thank you very much for your time.